The rule for ratio test is written right here at the top. It is the limit as n goes to infinity of the next term over the one that is given to us. A sub n is the next one, and a sub n is what is given to us. So when I have an example, let's see if we can make some sense out of this. I'm going to have the summation from 1 to infinity of 3 to the n over n squared. This is what you see right here is my a sub n. So that's going to be the denominator. What I'm going to end up doing is right here where this n is, I'm going to add 1. Right where this n is, I'm also going to add 1 for the top term. So it's going to end up being a complex fraction. It will end up looking a lot like this. Limit as n goes to infinity of, and it is absolute value. So the top will be 3 to the n plus 1. The bottom will be n plus 1 quantity squared over, and now we put the original 3 to the n over n squared. So when I go to simplify this complex fraction, I still have not taken the limit yet. I'm going to have, and I'm going to rewrite this one, this part right here, as 3 to the n, that's an n, times 3. So the top of my fraction will turn into 3n, 3 to the 1. There's a 1 there, that's what happened to 1. And then the denominator will turn into n plus 1 quantity squared times, and then the denominator will flip up, become n squared over 3 to the n. All that is fabulous. Now I begin to cancel. This cancels with this. So at this point, now let's rewrite my limit. I now have the limit as n goes to infinity of 3n squared over this n plus 1 squared. Well, I know that this denominator is going to make an n squared, so I'm going to look at my leading coefficient over 1, which will be my leading coefficient, so the limit here equals 3. Because 3 is greater than 1, according to my ratio test, this one diverges. Therefore, that's what the 3 little dots mean, diverges by ratio test. Okay, let me get you a second example. This second example has a factorial in it, and this is actually the one that gets used by ratio test almost always. So when we start to plug things in, we're going to take the limit as n goes to infinity. Remember, the top will become 2 to the n plus 1. The denominator becomes n plus 1 factorial. Over, and I'll go ahead and write it out long ways, but this is 2 to the n, that's an n, over n factorial. When I do a rewrite on this to start to simplify things, I've not taken my limit yet, so I'm going to have 2 to the n times 2 over, and this is, at this point, I'm going to write n plus 1 times n factorial. N plus 1 factorial, as a side note, is equal to n plus 1 times n. If you need it, it can be n minus 1 and n minus 2, and it keeps going. We only need to bring it down to n factorial because when we do what I call the keep change flip, you may have a different method, but this becomes 2 to the n. What I realize is this n factorial will cancel with this n factorial, and so kind of by looking ahead, you know what you need to drop that factorial down to. At this point, I'm back to taking a limit as n goes to infinity of, and all I have on the top is 2, and on the bottom I have an n plus 1. Well, that does equal 0, and because 0 is less than 1, therefore this diverges. I'm sorry, I did not mean that. Therefore this one converges. That's what happens when I think about the next thing, by ratio test.